What's up, everybody out there on the internet? We are here. We're here live, and we're here to talk to you about WikiChat. WikiChat is a real-time RAG application built on Wikipedia data and built with LangChain.js and Astra DB. This is an app that we built over the last few weeks to kind of show off what developers can build using modern AI tooling. And the purpose of this live stream is to take the app that we built and break it down into bite-sized chunks so that everyone watching can understand how they could build something really similar themselves. If you are a JavaScript or web developer who's new to generative AI, this stream is for you. So let's talk about a little, let's get into what we're going to talk about over the course of the next 45 minutes or so. We're going to make some quick introductions. There's three of us here on the stream right now. We're going to demo WikiChat. So if you haven't seen it yet, we launched it just yesterday. We're going to go ahead and give you a demo and show you what the experience looks like. We're going to dive into why RAG. Like, we'll talk about what RAG is and like why it's useful to build these kinds of experiences. We're going to dig into the code. So I hope you're ready for lots of JavaScript and lots of time in Visual Studio Code, because that's what the meat of this live stream is going to be about. And then the last thing we're going to talk about is how do you build chatbots that don't suck, right? Like, how do you maintain quality? How do you actually create something that you would put into production instead of just building a toy? A couple notes of housekeeping. If you are watching the live stream on Crowdcast, and I'm seeing there's a lot of you on Crowdcast, I'm seeing the chats flying in. Feel free to drop a chat and like let us know where you're dialing in from, and maybe let us know what you're interested in hearing about. But if you're in Crowdcast, you should see an option on the right of the screen to ask a question. There's like a little chat box that has a question mark in it, and you can use that to ask questions as we're going through the live stream. And then you'll also notice as people are asking questions, it's kind of like Reddit, right? Or Hacker News. You can upvote questions that like you want to +1 or that you want to see make it to the top. So feel free to ask questions. Feel free to upvote things that like you want to make sure that we get to. If you're on a different platform, if you're watching this on YouTube Live, hello everyone on YouTube. Same thing. Just there's a chat box on the right. Ask questions in the chat. We will do our best to kind of keep track of the questions that people are asking in the chat. And then when we get to the end of the live stream, we're going to dive into a little bit of Q&A, and we're going to try and make sure that all your questions get answered. So yeah, that's a little bit of housekeeping. So now let's go ahead and sort of introduce ourselves. So my name is Carter Rabassa. I'm the head of developer relations at Datastax. And I hail from the kind of wet and gray Pacific Northwest. I'm here in Seattle, Washington. And I'm going to be your MC for this live stream. We've got a couple of like actual real engineers on the live stream that are going to dig into everything cool that was built to kind of create WikiChat. And I'm gonna ask Alex and Jacob kind of, as you introduce yourselves, same thing. What's your name? Where do you work? And then very importantly, I want you both to tell the audience whether you are a semicolon person or a no semicolon person. Who wants to go first?
Yeah, happy to go first. Sure. I'm Jacob Lee. I'm the lead maintainer of LangChain.js. I'm super passionate about bringing all this incredible new technology and LLMs and this whole AI movement to web devs and kind of leveraging their amazing strengths to bring things in production. I live in San Francisco. It's also currently gray and a little bit stormy. I got caught in a rainstorm biking in today, unfortunately. And I am absolutely a semicolon guy. I will die on that hill.
But, okay, sorry. By the way, I realized that I didn't answer my own question. I'm super staunchly anti semicolons. So me and Jacob, we're gonna go like arm wrestle after this live stream. But Alex, you're up, and maybe you'll be the tiebreaker here.
Oh, I'm a super strong semicolon guy as well. And Carter told us he was going to ask a secret question. I was expecting something much more difficult. But anyways, I'm also from Seattle, along with Carter. I'm Alex. I lead our developer ecosystem team at Datastax. I mean, really, we're responsible for building kind of cool integrations with folks like Jacob. So super excited to share some of the demos we built and talk more about how you can build your own RAG chatbots.
Awesome. Okay. Well, by the way, I mentioned that those two fellows were real engineers, and obviously they think that semicolons matter. And like, I'm just more of a hacker. So I think semicolons are just superfluous and ugly. So I think that kind of like, I think this makes sense. I'm actually not surprised at all. All right. So moving on, you've heard us say the word WikiChat a few times. You're probably thinking like, what the heck is this? Why do I care? We're gonna dive into WikiChat and kind of show you what it is, and I'm gonna let Alex take that away.
Yeah, for sure. Okay, awesome. So kind of before we get into the code, we'll kind of show you the end product first. So this is WikiChat, and WikiChat is an app we built to demonstrate real-time RAG using Astra DB and LangChain. So what we've done in the background that you can't see here, but we'll show you later, is we've indexed the top 1,000 Wikipedia pages. And we also listen for new Wikipedia pages to be updated or created, and we immediately index them in our vector store. We're then using some advanced RAG techniques through LangChain to give our chatbot kind of real-time access to Wikipedia data. So what you're seeing at the bottom are questions that have been generated by an LLM based on which Wikipedia articles were most recently updated, right? So here we can see, here's some sports questions, right? This is displaying here because the Wikipedia page was just updated, right? So when I refresh this page, you will see a new set of questions based on which Wikipedia pages were just updated, right? So malware page was just updated, some other things. So we'll show you how this all works, how we're storing all the data in our database to make this work. And then we'll also show you the actual RAG piece, right? So when I click this question, in the background, we're generating a prompt with data from our data store. And we are giving you a response using the latest real-time Wikipedia data. Jacob will also show you we're really heavily using some of LangChain's new features that Jacob will show as well. But really, this session today will be focused on how you can build a real-time chatbot using the latest data, and actually why you need a vector store to build something like this.
Could you
sorry,
really quick, Alex? If you Command plus just increase your font size might help a bit.
There we go. How's that? Cool.
One more.
Oops. Cool.
Yeah, that's a bit better.
Don't worry, it's responsive design, so it'll look good.
Yeah, Jacob, that was a good test. If this app is actually responsive, it looks like we passed that test. Okay, cool. So before we really dig into the code, I think it's important to kind of walk through like why RAG is even necessary. So LLMs are trained on data at a point in time, right? If you want access, if you want your chatbot to have knowledge of like events or data after that point in time, you need to use RAG, right? You need to inject real-time information into the prompt. So kind of a really good, like easy way to understand this is by looking at like some documentation on OpenAI models, right? And on the right, you can see there's this training data field. And this is basically the cutoff date of, these LLMs are trained on all data up to April 2023, right? So if you wanted access to any Wikipedia data after April 2023, you would have to insert it, you would have to tell the LLM about it, right? Insert it into the prompt, which is why RAG is necessary. It's also super necessary. Imagine cases where you want the LLM to be knowledgeable of your business's data, right? Like imagine you're a doctor office and you want your LLM to have knowledge of patients. The LLM is trained on public information and wouldn't know anything about your patients. So you have to insert that data yourself. So really, RAG is a technique to give LLMs knowledge of either private information or real-time information, which we're showing today. There are two kind of
just like quick interjection, right? Like for folks that are watching, like the metaphor that I like to use is like that classic iceberg metaphor, where like the amount of data that's in the public, like searchable, indexable domain is like the iceberg above the water. And then the amount of data that actually like exists that companies and people care about is like the iceberg that's below the water. It's like 100 or 1,000 times bigger than like what Google is like querying or OpenAI is like indexing like on a regular basis. So it's like that's kind of like the metaphor I like to use in my head.
Totally. And there are basically two core workflows that we'll talk through today, right? The first kind of workflow is this data ingestion workflow, right? Somehow we need to take all of the existing Wikipedia data, embed it, and store it in our vector store. And then there's the actual RAG chain. So when a user asks a question, how do we query the LLM? How do we query the vector store to get the latest, to feed the LLM the latest information to get a relevant answer? And we'll walk through both those flows today.
Awesome. So I think, so now we are, I promised you all, we were going to sort of like exit the land of slides and spend time in code. So yeah, we're going to dive into the code. So I think Alex is just getting ready to cue that up.
All right.
And by the way, while he's doing that, all of the code that he's going to show you is open source on GitHub. And we'll provide links to a blog post that we wrote that sort of really is just a longer version of the live stream we're giving now and more detailed. So we'll give links to the blog post and we'll give links to the GitHub repo so everybody can see this code. So I don't want people like trying to, furiously take screenshots or scribbling things down. Like, don't worry about it. Like, we're going to give everyone this stuff.
Totally. And what's especially cool is you can run all this for totally free on the Astra DB free tier. So afterwards, you should totally clone all this code, go through the getting started instructions. We'll show you how to deploy all of it. And we have a super generous free tier. So you can run all this for free. Awesome. So there are really two core. So this is a Next.js app. So both the front end and the back end are sort of built into the single app. And there are really two core routes that drive this entire thing. The first is the suggestions you see at the bottom of the screen, right? So that is this completion route. And
Alex, are you able to, you're sharing your whole screen, right?
Yeah, totally.
Can you click over, can you just open the browser real quick just to remind people what those suggestions look like?
You got it.
Do you have that? Oh, I mean, if you're sharing your whole screen, you could have just clicked over to the browser, right?
You're right. I did that in the least efficient way possible.
No worries. Hey, like I promised Alex and Jacob that we're gonna have fun on this live stream, so no worries. But there we go. So cool. So these colored blocks, like these are the suggestions that that the app is constructing when the page loads, and that's what you're showing people in that route right there, right?
Exactly. Yeah. Okay. So the first route builds these cool colored boxes right here.
Sweet. All right. Sorry to interrupt. By the way,
that's good.
Alex and Jacob, like my job is to wear the hat of like the regular average developer and like, ask the dumb questions. So I'm fulfilling that promise.
So far, so good. Cool. So that is this completion route right here, and it's really pretty basic. So at the top of the screen, we are importing the Astra DB and OpenAI libraries. We have some setup here where we configure the environment variables, right? So for Astra, you need to configure a DB token and DB endpoint. For OpenAI, you need a key. And then we get into the actual route. So all we're doing here is we are taking the 5 most recent article updates, right? And we have that stored in Astra DB. So you can see that right here. As we're indexing Wikipedia, we keep track of the most recently updated articles, just right here, URL and title, and then the chunks as well.
Right, and then I think so for folks listening at home, there's a process, there's a cron job that's like that's always running, that's receiving these real-time updates from Wikipedia, and then Alex, in the database, that's just a single document that is effectively being overwritten every time we get new documents from Wikipedia, right?
Exactly. That's exactly what it is.
Cool.
And then all we're doing to get the suggestions is we're just making a database query to pull that one document you just mentioned, Carter.
Yep.
We do kind of some small cleanup, right? Getting rid of any of the the JavaScript keys that aren't necessary. And here's where we get into the really interesting part. So we're using an OpenAI function to categorize as well as return clean JSON. And then here's the actual prompt. So really what we're doing here is we're feeding that one document that Carter mentioned with the most recently updated Wikipedia articles. We're feeding it to the LLM to generate questions, right, that are relevant to the most recently inserted articles in Wikipedia. So that's kind of the first component. And then, the second big component is the actual chat, right? So now we have these suggestions. How does the actual chat work? So that's a different route. And that's also pretty basic. And Jacob will kind of dive in more to exactly how that works. So
yeah,
here,
absolutely.
Yeah, and just just for folks that might be a little bit new to Next, so this is a Next.js app. Next is pretty popular, but maybe not everyone has used it. This is a full stack JavaScript application. The code that Alex just showed you runs on the server side. And the way that you kind of know that is that inside the project, it's under a directory called API. So when you see these modules under the API directory, you know that you're dealing with code that's running in a server-side context. That's actually like pretty important because your database, like almost all the stuff you do with credentials, your database credentials and OpenAI, like those are credentials that are like only running on the server side. Other parts of the app will run on the client side as React app, as sort of like React components. So yeah, just for folks that aren't familiar with Next, like right now we're sort of like looking into these backend API routes, and then maybe if we have time, we can look into like how the actual sort of React front end was built too.
Exactly. And this route gets a little bit more interesting, and Jacob will talk about later like how all the chaining works. But essentially, when the user asks a question, we have these prompt templates right here, right? We have two prompt templates. Jacob will explain later how we use both of them. But essentially all we're doing is we have this prompt, we're feeding in the relevant Wikipedia articles, right? Like the user asks a question, we do a vector search, we feed in the relevant Wikipedia articles, and then we ask the actual question to the LLM. And through feeding in all those relevant Wikipedia articles, the LLM has all this knowledge that it wouldn't have in its base kind of training data and is able to answer these really specific questions related to real-time Wikipedia data. So here we're kind of constructing the prompt. We use LangChain prompt templates, which are a really simple way to kind of inject variables into like prompts that look like this.
Alex, do you mind scrolling back up to the top of the file?
Yeah.
I think the imports are pretty interesting. So there's like, so Jacob can probably speak more to like what the sort of breadth of the LangChain JavaScript SDK is, but there are a lot of like really interesting types that we're importing up here, like runnable branch, runnable lambda. Like it's in fact, and beyond like those core bits of the LangChain SDK we're importing. Like Alex, you'll notice like we're actually not using the Astra DB client directly. We're instead importing some of the connectors that we built between Astra DB and LangChain. I don't know if you want to speak to that.
I'm happy to jump in as well here. This might be more. I don't actually think we ever explained what exactly LangChain is. Maybe that'd be helpful to folks as well.
Yeah. This is a great time.
Go for it.
Awesome. So yeah, for those who aren't familiar, LangChain is a orchestration framework for a lot of these pieces and other tools and components that are useful when working with large language models, LLMs. Vector stores are one piece. Things like embeddings, which are essentially specialized AI model that can turn raw text into a sort of like machine readable and searchable format. So you see Cohere embeddings above there at the top of the screen. And that's going to use Cohere's, basically call out to Cohere's model. And one of LangChain's main value props is that it can take all these different providers and all these different tools and provide a standardized interface and a standardized way of like basically directing the flow and chaining, as the name implies, a lot of these pieces together. So yeah, some of the, I already mentioned embeddings, but other primary sort of base models that LangChain uses, prompt templates, which Alex mentioned, which are responsible for formatting the input into large language models. Then there's the large language model class itself. So you see import chat OpenAI below there, where we're using OpenAI's GPT-4, I believe, or I think there's a few options to basically act as the brain for our chatbot. And then you have output parsers, where you see a string output parser there, which are responsible for formatting the output of an LLM into a format where we can use it later down the stream. So
and just sort of, and I'm calling this out for devs like on the stream, because like, look, in a world before LangChain existed, like, what are we doing? Like, you know, we are manually stitching together API calls, right? Like, we're calling the OpenAI API call, and we're calling Astra's API, and like, there's all, you know, and we're dealing with that orchestration manually, like in, you know, in Python or JavaScript or whatever our language is. Like, Jacob will go into more detail, but like the cool thing about LangChain is that they've sort of just they've taken a bunch of like best practices and abstractions that have organically kind of like come up through people building on AI, and they've built it into, you know, a prescriptive SDK that developers can use. And I just wanted to call out, like, all these imports, like, they show you that, like, you know, we're not sort of manually like interacting with anything other than LangChain, right? Like, but we are taking advantage of a lot of the integrations and connectors that LangChain has to this ecosystem. So, and that was different than the route that Alex showed you before. That route was pretty like vanilla, you know, a vanilla kind of RAG, but we're doing more complicated things here, which is why like LangChain like really shines. Anyway, sorry, we can kind of get back to the code.
Yeah, absolutely. No problem. So yeah, I think some of the key things, you can keep it at the top for a minute, Alex. One of the key things that, you know, I think a lot of folks working with LLM struggle with is streaming. And a lot of these kind of operations that, you know, work with LLMs tend to be very long-running API calls, or things that, you know, you want to, when you're building a good UX for a end user, you want the kind of initial response to be fast, and like you want, you know, you don't have someone waiting for 5 seconds to see your chatbot's response. So a lot of what goes into LangChain is, and you'll see these runnable classes up there. We've put a lot of focus onto making this kind of initial response and like working with streaming and all these like sort of tricky things as seamless as possible. So when you construct chains using these runnable classes up there, and some of them are, you know, if you're not familiar with Python, you might not know what a lambda is. A lambda is essentially like a function. A map is like an object. Sequences like are kind of named for like a chain of these things together. What you get out of this is sort of streaming out of the box, and you'll see below, actually, the bottom of the imports, Alex is using the Vercel AI SDK, which is an excellent one for working with Next and like front end chatbot rendering. We play very nicely with them. You can just pass and actually now if you scroll down, Alex, maybe to the response object at the bottom.
Yeah, he's gonna like where
there's a few things there.
The very bottom where the streaming happens.
Yep. So you can actually just pass you'll see at the very bottom, and I'll go over some of the steps that we go through to construct that await chain little line you see there. But you can just call it .stream and then pass that stream directly into an HTTP response object, or a Vercel one, as you can see here.
Yeah,
you can get that kind of streaming experience.
Alex, can you, without stopping sharing, can you just click back over to your browser?
You got it.
Yeah, and can you maybe ask another question or click on a different prompt? Because I think people take it for granted, but like when Alex clicks on one of these things, look at how the actual response from the chatbot like streams. Like, you might think that that's just like a gimmick, like we're just sort of getting the fully loaded thing into the client, and then we're just kind of creating this like fake streaming like thing. That's not what's happening. Like, there's a real HTTP stream of data that's exiting the server side and like coming into the client at that point. Yeah, and it's awesome. Oh, and then Alex, did you want to click on the link to like show people in Wikipedia like like how recently that was indexed?
Yeah, this is like the best demo of the real-time component. But if you click this link at the very bottom and you click view history,
yeah,
you can see.
Oh, wow.
Yeah, I mean,
so it's like,
by the way, in case people think this is all contrived and we made it up, like, no, this is like, this stuff is all being indexed like right now in real time via Wikipedia's server-side events API. It's pretty cool. It also does yield, I mean, it is pretty random, like what pages are being updated right now. So, you do get some pretty random Wikipedia pages in WikiChat when you load it. So it's fun though.
Last night I got a lot about Slovak football, which was
yeah, right.
sort of a funny one, I thought. Yeah.
I don't know what time you're awake and like what what parts of the world are like actively editing Wikipedia. And by the way, thanks to Jason for sharing the link to WikiChat in the chat, and we probably should have shared that more clearly in advance. It's wikich.at.
We're also using an LLM to categorize each of the questions. So these icons and colors are specific to like the category.
Well, let's go back to the code, because like that's there. And Alex, I'd say like in terms of like Jacob, you might want to, maybe you can drive or someone can drive, but I feel like we should probably like can we go to where the post starts executing? There's a lot of setup, there's lots of templates and stuff, but I think like explaining. So here we go. Yeah, like this is where the actual post is being made from the client back to the server side, and maybe kind of starting here and walking through it. It'll help get us to the meaty parts where we we get like sort of we use JSON schema to get like well formatted data from OpenAPI. We use an LLM to actually like create better questions to create better. There's a lot of cool stuff happening here.
Yeah, Jacob, I could walk through these first couple of lines, and then it'd be interesting for you to walk through.
Yeah, absolutely, sure.
Yeah, cool.
Yep.
So these first couple of lines are pretty basic. So first, we're taking we're grabbing the user's messages and the LLM they selected from the UI, right? So we allow users to select which OpenAI model they use. Here we are instantiating the Cohere embeddings client. So we're using Cohere to embed all the questions.
So for people, once again, like I'm just sort of the average dev, right? So we've already heard about OpenAI, and I think everyone's heard about OpenAI. Maybe not everyone's heard about Cohere. So like, what is Cohere, and like, why are we using it instead of OpenAI?
Yeah. So before you store data in a vector store, you need to convert the raw text to vector embeddings. And you do that using a embedding model. So Cohere is just one of many embedding models you could potentially use to actually create those vector embeddings. OpenAI also has their own embedding model. We've seen really good performance with Cohere lately, so we've been kind of leaning towards using that for our examples. But you totally could also use the OpenAI embedding model for this use case. The most important part, though, is you need to use the same embedding model when you perform the data ingestion step in the actual RAG query. So you can't like embed all your Wikipedia data with like OpenAI and then query it with Cohere. So that's the only kind of thing to keep in mind.
Yeah, some people in the chat have already asked, like, hey, like, how do you fit, so they've asked questions about like, how do you fit stuff into a limited context to get good results? Like, that's for folks that are watching, like, don't worry, like, that's coming. That's sort of like the whole, that's the why behind the vector store and the vector search. And we're actually almost there.
And we're using LangChain to do that, sneak preview. And I guess I'll hand it over to you, Jacob, to walk through the next pieces.
Yeah, totally. So as Alex said, we've set up a few pieces up at the top there. An embeddings model that we'll use to the way vector search works, you need to actually search using a vector as well. So that's why, in addition to ingesting Wikipedia, using and embedding it with this model and creating this machine searchable representation of our data, we're also going to search against it with a machine searchable representation of our user's search query as well. So the way this, the kind of basic flow here, and we set up an OpenAI model as well and an Astra DB connection for our vector store, and that's what we use to actually search through our data using this. Essentially, user question comes in, we embed it using the Cohere model, and then we search the Astra DB vector store using that machine searchable representation vector as our query, get some relevant information back, and Alex will go more into how we prepare the data for searching later. But then we take those retrieved chunks and pass it back to the model for final augmented generation.
Yeah, and
there's a few steps here.
Sorry, I'll interject very briefly. So like for the folks at home, right? So a vector, we should probably create like some slides here for this stuff, right? But a vector is just like an array of floating point numbers, like just in case people didn't know that, right? And a vector database is just a special kind of database that can store these arrays of floating point numbers. And think of like, think of three-dimensional space. We have like three numbers that indicate like a point in three-dimensional space. These vectors are like n-dimensional. So like, I don't know how many dimensions Cohere has. Alex, do you know off the top of your head how many dimensions?
Like 1024, yeah.
Right. So Cohere, when you take a chunk of like English language text and turn it into a vector, it creates an array of 1024 of these numbers. But the point of the vector search is that like you can then take a person's question. You can say like, who is the villain of Star Wars? And the question gets converted into a vector, which is in this n-dimensional space. And then because you've already created embeddings for all this other Wikipedia data, the vector database basically finds the other vectors that are closest in this n-dimensional space to the question that people asked. And that's what's happening on line like 110, right? Or I guess maybe not. That's where we define the retriever, but like when the actual query happens, like that's exactly what's happening. Like we're taking that question,
yes, well said,
into a vector, and then and we're getting those closest things back. Is that a fair sort of description?
Yeah, I think that's well said.
Awesome.
And here we're saying grab the 10 most relevant results.
Yeah. And then if we go, and then Jacob, if we go, Alex, if you scroll down, like a lot of these functions that you're seeing they're sort of helper functions, but the actual core chain that we define is farther down.
Yes. So a lot of these, by the way, will be, you don't need to use these runnable classes, a lot of them anyway, because it will be coerced if you put them, they'll be translated automatically into the proper format when you use them in a chain. I think Alex has used the classes here because we're labeling them for tracing later on to make sort of debugging it easier.
So
we'll show off a bit later. So if you scroll down a bit farther to, sorry.
Yeah. No. Yeah, I was going to say like, we're gonna talk about the debugging later. That'll be really fun.
Yeah. So you see this const chain runnable sequence from. So essentially what we're doing, and kind of the core crux of this flow, we're taking our initial question. This is what this chat chain. You can see run name chat chain. That's what we're labeling it as. And we're going to either, depending on whether there's chat history or not, perform some transformation of the user's query to make it easier to search on. Then we're going to map that question and any other retrieved context into the prompt. Then we're going to use all that context, pass to our GPT-4 model, and generate some final answer based on the retrieved data. And that's kind of that's the basic retrieval augmented generation flow.
So basically, line 139 to 145, like you all should just think of that, like that's kind of like the LangChain program. Like that is like the program that you're setting up for LangChain, and then that sequence starts to execute. And there's a bunch of like really interesting rules about like how it executes and like how that information gets logged. But it's pretty cool. And like Jacob, we have I think some people might be wondering about like what you said about like generating better questions. I think we've got some slides where we kind of like we speak to that a little bit. Maybe we should just pull those up. And like help kind of ground people and like what it even means to like generate like a better question.
Let's do it.
Yeah. So like what's up with this query transformation?
Yes. So general basic sort of simple retrieval flow, again, just to reiterate, we have a user asking a question. We pass that question to our embeddings model, in this case, Cohere, that has a vector store to search over. And that's going to be Astra DB in this example. So we have a vector store with all this ingested Wikipedia data. We have an input user query that we translate to a vector, a machine searchable vector using Cohere. We search for the vector store, retrieve the top 10 relevant documents to the query, pass all that to the LLM, and generate a final answer. So that works well enough if you ask a single question. And this is what I mean. I think a lot of chat bot design, you can start very simple and get a lot of mileage, but it's always that last 10, 20% that it becomes kind of a little bit more optimized and a little bit more, takes a little bit more thought. So if you wanted to take a sort of red team approach to this, like how would you then mess this up, quote unquote, or like what's a sort of user way, a common question a user might ask that could throw this off? And it turns out a very simple and very, very common one. If you go to the next slide here. Okay, so here's an example of a basic one: how do bears hibernate? And what would happen here is, I got ahead of myself a little bit, apologies for that. If you ask the question, how do bears hibernate, that gets translated to a vector. We search the vector database, Astra DB, for documents related on bear hibernation, and maybe we get some results back and generate and all's fine and dandy. Now, let's say though, if we go to the next slide, a really common kind of follow-up to that might be, okay, that's really cool. Tell me more about how bears hibernate. But, maybe a user typing it would just say, tell me more about that. I want to learn more about bears hibernating, but of course they don't explicitly say hibernating and bear. So unfortunately though, our vector database acts on similarity search and doesn't have any context as to sort of like what the users asked in the past. They only know what they're passed statelessly. So if you were to, yes, exactly, Furquan, exactly. So you wouldn't even get information on how other animals hibernate. You just get, tell me more about that, which is very generic, and you get sort of arbitrary retrieved documents that may or may not have to do with anything relevant. So to get around this, a pretty common optimization we do is this example of query transformation, where we take the input query, tell me more about that, and you can go to the next slide, Alex. And we pass that to an LLM to basically transform that initial query, taking chat history into account. So we dereference the pronouns that and into something that's more, basically free of these pronouns and references to chat history. So instead of tell me more about that, we would then search our vector database for go into greater detail on bear hibernation or something similar to that. And we would get more documents on bear hibernation, and our LLM would take those documents, see what it responded with before. We would also pass in the previous chat history and be able to synthesize something based on maybe mentioning more information from the source documents that it didn't get into the first time. So yes, you can go pretty deep. This is one pretty common optimization that comes up a lot because people tend to interact with these bots conversationally. So this is one way of handling that.
That's awesome. So I think we should get back into the code because Jacob, that was an awesome explanation. I love the bears hibernating example. Like my sort of favorite example that I was using when we were debugging WikiChat is, first you ask the WikiChat, who is the villain of Star Wars? And then of course, WikiChat is brilliant and it returns the answer Darth Vader. But then the second question you ask might be, who are his children? And and of course, you're looking for the correct answer. Looking for like Luke and Leia. But then, without the benefit of having the chat history, the LLM just doesn't know who you're talking about, right? So I think here in the code, this is it would be great to kind of walk through like, oh, well, then how do you solve that problem, right? Like how do you actually use the chat history to create the better question?
Absolutely.
Yeah,
so if you scroll up a little bit, oh, you got it.
Oh, sorry, go for it.
Yeah.
I was just going to walk through. That's exactly why we have two prompt templates. The first is for that initial bears question, right? And then the second is, now that we know we're asking about bears, here's the follow-up question. And Jacob, it'd be really interesting if maybe you can talk through like the conditional chains a little bit lower in the code?
Sure. So, that the step is there's trade-offs to everything when designing chatbots. So generally more LLM calls and more kind of it's not, obviously there's a upper bound, but the more you call the LLM and the more reasoning you can kind of inject into your app, the better it's going to perform. The cost, however, is latency. Obviously, these LLM calls tend to be a bit longer, and you don't want to keep your users waiting. So what Alex has optimized here is this chat history check, where you only do this query transformation if on an initial question. You don't, on a follow-up question. You don't need to do this initially. In fact, you don't want to do this initially because the LLM may transform your question into something that's not quite what the user is asking for originally. So this is kind of a nice optimization where you keep the latency low for initial questions, but then you have this nice ability to handle reference-full, context-full follow-up questions afterwards.
Absolutely.
Alex, do you want to kind of go back up to where that prompt? I think some people are asking like specifics about these prompts, right?
Oh,
so if you
okay.
if you look at the see like right there, this condense question template. Alex, maybe if you could like make it bigger by one more increment.
Plus,
you got it.
Like Apple Plus, baby. It's your friend. Nope, that was the wrong way.
The opposite way. Zoom in.
Yes,
yeah, like there's a couple really important things that we should cover for folks. Like one, it's like, so given the following chat history, like, and a follow-up question, I guess, can you word wrap that? There's a view word wrap option in Visual Studio Code. If you just go to view and I think there's word wrap, turn word wrap on.
And one thing with the formatting for chat history there, you'll notice it's in these kind of HTML looking tags. Different models are trained on different data. OpenAI's models are pretty good at parsing out, and Anthropic's as well, and a few others are very good at parsing out these tags because they're trained on all of this data. So it's a convenient way to delineate where different parts of your prompts might start and end.
Yeah. Awesome. That's great. So if we go back to, so basically what people should take away from this is that the actual question that came in from the user was something that was not specific enough. And then in the actual LangChain sequence, we're making a call. Well, there's a Boolean test. There's a Boolean test. Let's go down and I just want to make that crystal clear for people. There's a test down. So right on line, no, go up. Well, go down to like the sequence.
Should be runnable branch, yeah, right there. That check there.
Yeah, runnable.
Condensed chat branch, I believe. Yeah.
Exactly right. So that right there, there's a Boolean check that says has chat history check, right? And we don't need to bother to look at that how that function is defined. It's a one-liner. Like all it checks to see is because remember at the very top of this post, Vercel, like we haven't talked enough about it, but the Vercel AI SDK is doing a lot of like really useful work. Someone in the chat asked, where is the chat history stored? Is that stored in the database? No, like the chat history is stored in the client. Like the chat history will go away the minute you close your browser. But as long as you're using the web application, the client is keeping track of your chat history and it's passing the chat history to the server side, to the API route that we're building. And then this function is just checks to see if that messages array that was passed in is like, non-null or like, has more than one element. And if it is, then it uses this chat history question chain, which is the prompt that you saw before, where we use an LLM to build a better question. And then else, and this is where you kind of have to learn how LangChain works and like how the JavaScript SDK works. Like the else is this no chat history question chain, which is basically kind of a no-op. Like it just feeds the question that the person asked to the LLM. It doesn't do this query transformation that Jacob described before.
Yeah, and you can use a function for this, by the way. A lot of this was done to make tracing smoother here, but you can also use a function to route between different chains or different execution paths, essentially.
And by the way, this is I think this is the perfect transition point. So like, once again, this is all open source. Like, we could kind of go line by line and break this up, but I think we've talked about the most important parts. Jacob, do you want to take over? And do you want to take over
Absolutely.
and show off LangSmith?
Sure thing. So I think let's see. There we go. Cool. Screen.
And while
Yep,
Jacob's
cool.
pulling this up, if you do go look at the code, you will notice that many of the calls that were made in JavaScript to the LangChain JavaScript SDK were appended with this with config command, and where we passed in some special strings. And you might have wondered when you're looking at the code, like, what's that for? Well, Jacob's going to walk us through that.
Yes. So again, as I alluded to before, building a chatbot, it's very, I wouldn't say trivial, but it's pretty defined how to get like kind of 80-90% of the way there. But if you want to get to that 100 and you want to make sure that what you're putting in front of your users is going to work and it's going to be reliable, something that's going to bring delight and that they'll enjoy, you need a lot. You can be a bit more thoughtful and a bit more robust on how you're like defining your processes and like how do you test and how do you evaluate performance. So one way to do that, and one thing we've been working hard on at LangChain, is observability, debugging, evaluation, and tracing tool called LangSmith, which integrates very easily with sort of the LangChain framework, the open source framework. You just set some environment variables, and you can get this sort of X-ray vision into basically what's happening with your chain and debug certain steps. So to show this off, what I can do is I can ask a question here. I asked this earlier. Hopefully it's still in the top 10,000 articles, but how many subspecies of tiger are there? And if I ask this, it's going to go. It's in GPT-4. So give it a minute here, but it should start streaming. I can switch it to turbo if it doesn't, takes a little bit too long here. Yeah, let's try switching to turbo quickly. 4 is very slow. Come on.
No worries, man. If this isn't pulling up the data fast enough, we're probably overloading the servers a little bit right now.
Oh yeah, okay.
It's okay. We can switch over to. I think people are having a lot of fun playing with WikiChat right now.
Yeah.
we can just transition.
Okay. Here we go. Yeah.
Okay.
There we go. So I've asked a question that was sort of in the recommended responses here. Who are the members of Brooklyn Duo? I'm not even, it looks like they're a band who maybe married, and you can see the source here, which is great. What I've done is set up tracing though as well for this. So maybe some of you playing with this app in yourselves may have seen this view trace button here. If I click it, there we go. I can see that I get this sort of view here with LangSmith. And I can see some of the steps that this chat chain goes through to come up with this answer. So my question is here: who are the members of Brooklyn Duo? I can see the answer. But I can also see, for example, like what Astra is retrieving. So I can see that we asked the initial question, who are the members of Brooklyn Duo? And Astra DB is going in and figuring out, retrieving some documents that are relevant. So actually the first hit here is pretty good. Brooklyn Duo is a classical crossover ensemble consisting of Marnie Laird on piano and Patrick Laird on cello. And I can also see exactly what our chat model here is doing with this information. There's a few steps for processing here, but you can see things are labeled. That's why Alex affixed everything with those run names, is because they'll show up nicely in LangSmith, and you can see sort of exactly, get a better sense of what exactly each step is responsible for. But at the end of the day, my OpenAI call is taking this prompt. It's taking the context retrieved from Astra DB. So Brooklyn Duo is the classical crossover ensemble. And then you can see the output is sort of what we see on screen here. So this actually seems pretty good. But let's say we got a response, and I've prepared one. I had to make sure that I would get a bad one at some point. So I prepared one ahead of time here. So let's say we get a response that maybe isn't quite what we wanted. So this is one that included a follow-up question, but the initial question was, what teams made it to the playoffs? What arena do they play in response to what teams made it to the playoffs in the 2023 Canadian Basketball League season?
Yeah, so hold on. I'm gonna pause. Like, I know Jacob said it,
Sure.
but I'll repeat it, right? Like, the question is like vague. The question is like, what arena do they play in? So if you ask like, a chatbot that question, and it's like a naively implemented chatbot, like, who knows what kind of response you're going to get, right? But in this case, we have the benefit of previous messages included in the chat history, and now Jacob will sort of like pay off like this awesome query transformation bit.
Yeah, exactly. So the response mentioned from the agent mentioned a team called the Vancouver Bandits. And that's kind of what I had intended this follow-up question to refer to. But you can see my chains output somehow interpreted this as the Canadian Elite Basketball League does not have a specific arena where all teams play. So clearly something got mixed up with the transformation sort of dereferencing step. And what I can do here is I can say, okay, let's figure out why. There's an OpenAI call here that is responsible for the query transformation. And what I can do now is I can click it. I can see exactly kind of what went into the prompt here and why maybe what the output was. And I can see that the output got transformed to what arena do the teams in the CEBL play in? My expected response was, what arena do the Vancouver Bandits play in? So to help debug this, I can actually use LangSmith's playground feature, where if I click it now, it opens the prompt here and the output here, and I can try different models. I could try different, maybe it's GPT-4 versus Turbo issue, different temperature, various things here. Or I could even mess with the prompt and say, try to get it to massage it to a point where I can feel confident that it's going to sort of handle this kind of question well. So let's see, maybe I could change it to, here's a pretty canned example. All references, Oops, refresh that quickly. All
and Jacob, while you're
references
while you're writing that up, you enable traces for all WikiChat questions, so users can check out their trace. There's a public trace page for every time you ask a question. I'm so really encouraged to try that out if you haven't.
So one thing I glossed over is there's a private versus public view. The view trace button will take you to the public view, but if you're debugging, you'll have more access to these this lower level functionality in the private view. The public view is really to give you a sense of like what's happening internally and share with other folks to help debug. So if I maybe add this sentence, let's try out all references should be as specific as possible. Let's try that. And let's maybe turn down the temperature too to make it a little bit less random. And now if I press start, I can see, okay, all references should be to specific teams, perhaps. So you can do some prompt engineering here. Yeah, and here we go. What arena do the Vancouver Bandits from the 2023 CBL season play in? So you can see you can do some iteration here. You can sort of like prompt engineer and get some sort of like, maybe I like this prompt and maybe I'll push the next version of my app up. But how can I be sure that then it handles other questions well? Let's say, this prompt might handle certain things well, but not questions that you don't want any regressions is what I'm trying to say. So one way to do this, LangSmith has this, in addition to this debugging view, there's this one, I believe, we also have this concept of data sets, and you can basically take responses and say these are the set of questions or a representative set of questions that I want my app to handle no matter what. Like any changes I make to my prompt, my architecture, my structure, I want to make sure that I'm not going to have regressions on some kind of easy question. I don't want my users to get mad at me. So to do that, you can use this feature called the annotation queue. So let me, I'll just create a new one for this, WikiChat. And I can send this run, which was a real user, a real question I asked earlier, to this queue. And you can see that the response here is kind of bad because it took the wrong, it didn't get the right reference. So what I can do here is by hand manually annotate this to say the Vancouver Bandits play in Vancouver Arena or something along those lines. I can annotate this and then I can actually add it to a data set. Let's say WikiChat runs. And then once I have this in my data set, I can view the data set and see that, yeah, I have this basically question input with the chat history and then some output. So once I have this in my data set, I can actually run future versions of my app or my chain against this data set and evaluate performance. So let's say I do make that prompt change earlier that that you saw, where I tried to make the rephrase step as specific as possible. I can test that new version of my app against pre-existing chat runs and data sets and make sure that my response is still what I expect it to be. And we have a few different mechanisms for evaluating that. One is by hand, of course, slow and tedious. There's ones various using LLMs as a judge to say, is this a good output for this input? As well as, various kind of intermediate or like other ways of evaluating correctness. So you can basically run new versions of your app against previous golden data set or like sort of runs that we expect it to perform well on and get scores and sort of like evaluate and only push when we're confident and comfortable with putting this in front of our users.
Awesome. Dude, LangSmith is super cool, man. This is really great.
This is awesome. There were a couple questions around LangSmith is in private beta right now. How do I get access?
Yes. Yeah.
Sure. So yeah, I'll put this in the chat right here. We're planning to go to GA shortly, but you can use the code LangSmith Partner 2024 when prompted, and I've put that in the chat here, and that'll get you access. Oh, I think I put that in questions. Let me put that in chat.
Yeah, yeah. So Jacob will put that in the chat. There you go. Yeah, LangSmith _partner _2024. Definitely check it out.
Hey, Shir. That's my friend.
Nice. We're getting to the end of the hour, and I'm so I think we're gonna start to wrap things up. I did want to get to a few of folks' questions. So one question that Shani asked is, can you constrain the output to only use Wikipedia articles, as opposed to like the underlying information that that the LLM was trained on? Like that's what Jacob means by prompt engineering, right? Like it's a little bit of an art and a little bit of a science of constructing these prompts to keep the LLM focused on the data that you're providing via the context. And then once again, like we'll do a better job of sort of helping you all to visualize this, but like that's the point of the vector database. Like I want you to imagine that all of this is not true today. This is something that we're trying to figure out and work on, but imagine that all of Wikipedia was run through an embedding engine and stored in a vector database, like all of it. Like that's not true. Like that's not true today with WikiChat. WikiChat has, tens of thousands of articles, but Wikipedia has like tens of millions or maybe a billion. But all of that stuff. But then when someone asks a question, when they ask what's the capital of Washington State, that question is turned into a vector. That vector is used to find the 10 most closely related vectors in the vector database. And then it's only those 10. And then when we query the vector database, we don't just store the vectors. Like Astra DB isn't just a vector store. It also can store all the other kinds of data that you would expect to be able to store when you're building applications. So when we get those 10 documents back from Astra, sure, we get the vectors, but we also get the actual text that was used to generate the vectors. And then that text is what is passed as context to the LLM. And then the prompt tells the LLM, do not dare respond with anything that isn't related to the context that like I'm passing you. So I hope that helps. I mean, it's like, we're all new to this, and I think we're all getting better at it, but that's sort of the high level of like what you're trying to do to have more confidence in the answers that are coming back. I don't know if Jacob or Alex want to expand on that.
It's very hard to get a guarantee. I think the best you can do is sort of, like Carter said, be very deliberate in how you're prompting, and sort of say something like, use only information provided by the context that you're given. You don't know anything else, or you're a researcher or something. Giving it a persona can really help. You can also do like sort of a post check where you sort of say, hey, given this answer and these sources, is this like relevant? Or, is there some information that's not included in this source? That obviously adds a lot of latency and will ruin your streaming ability, but can be a nice like post, it's sort of like a online evaluation almost, if you really, really need accuracy. But again, you do lose a lot of those nice latency features, or latency advantages, rather.
Yeah. Sorry, I'm scanning through the questions.
I'm happy to talk about local models, actually. Shir had a good one in chat.
This is interesting. Like, what does it mean that the LM is not using my data to train? Actually, well, I'm sorry. Let's, Jacob, which one were you looking at?
No, go for it. Yeah. I know we want to keep it sort of focused, so.
No. What was the local model one?
Sure. Shir asked, I'd also be interested in how we could integrate with more local models like Llama or Mistral. So there's a few really nice ones through Ollama. I'm a huge fan of them. I shut them out whenever, but they essentially let you run and pull a lot of these open source models like Mistral, even if you have a powerful enough computer, or Llama 2 and smaller ones there. And LangChain has adapters for all these different, and connectors for all these different providers, including Hugging Face as well. So you can play around with it and use a lot of the same code that you'd use for OpenAI with these local models as well. Sometimes they do get a little bit wild. They aren't quite as refined in how they handle different kinds of prompts, but that's one of the nice things about LangChain is it lets you experiment with a lot of different models as well as embeddings.
Awesome. Well, we're now. Oh, Alex, go for it, bud.
Oh, sorry. Like literally, you're just importing a different package, switching out a line of code, and you're all of a sudden using a totally different embedding model or LM. Yeah, cool.
Yeah, that's that's just one of the benefits of something like orchestration, like layers like LangChain, right? It's what's useful about the abstractions that they've created, right? Like as a developer, like I don't have to learn the OpenAI API, and I don't have to learn the Cohere API. Like I can just I can choose to learn LangChain, and then I have these like pluggable abstractions and components that I can use. I mean, there's trade-offs, right? But it's like it's a pretty positive trade-off for most of the things that developers are trying to build, especially because like these things are all new, and really like getting it right the first time is almost impossible, right? Like building really good generative AI applications is going to require you to spend actually less time writing code and more time like trying out different LLMs and like trying out different prompts. Like, which by the way, developers might be like, they might not want to hear that, right? It's like, you're going to write less code, but you're going to spend more time on like crafting prompts, but it's kind of the future a little bit, I think. And I think, look, I think this is a great place to leave it. We for folks at home, we had planned to do this. We were actually worried if we could even make it to 45 minutes, and we've like blown past an hour. There's like too much stuff to talk about. It's way too fun. I just want to thank everyone for tuning in, and I want to thank Alex and Jacob for like all the awesome information that they've shared, all their prep for this live stream. Jacob has shared the promo code to sign up for Langsmith. So if you haven't seen it yet, it's in the chat, and we can maybe try to find a way to share it out later. It's kind of on the down low, but not exactly. So we probably won't put it on Twitter. And then
yes, please don't share too widely, but all of you fine people.
We're in the trust tree. So like everyone who's here, like we're all not going to do that to Jacob. Otherwise, he won't be able to share fun things with us anymore. And as Alex mentioned, like Astra DB is like completely free for developers to sign up for and play with, and it has like a really, really generous free tier. Like Alex and I both work at Datastax. We spend way too much time on Astra DB and playing with it. We'd love to hear your feedback. You can find me on Twitter. I know you can find Jacob on Twitter. We like check it out, sign up for it. You know, if you have any feedback whatsoever about the product, like find me. You know, I'll share my contact information. And then once again, if you want to dive in to like how we built WikiChat and all of the code behind it, go to the Datastax blog and find the blog post that we published yesterday on WikiChat. It goes into tremendous detail, line by line, on everything that we did, and it has links to the open source repo. So with that, I just want to thank everyone again for tuning in, and I think we're gonna